Today we're going to learn a new method of solving systems of equations, and we're going to use what's called the inverse of a matrix. So before we can get to solving systems equations involving inverse matrices, we first have to figure out what an inverse matrix is. So that's where we're going to be starting today. Okay, so by definition, an inverse matrix is, so the inverse of matrix is, and so if I'm doing like matrix A, so if I have matrix A, the inverse of matrix A would be A, and you have this -1. That's our notation for inverse. So you make sure you get that notation down. So it's the name of the matrix raised to the -1 power. So that's called the inverse matrix. Might be familiar with, that's the same notation we use with the inverse of functions. You know, we did f to -1. Okay. So a function is considered inverse if one of these things occur. So if I take my original matrix and I times it by the inverse of it, I will always get the identity matrix. And what's really cool about these inverses is it doesn't matter which order I multiply it. Most times in matrix multiplication, remember, order does matter. But here, if I take the inverse of my matrix and times it by my original function, my original matrix, I will still get my identity matrix. Now, this is also the first time we've seen this notation. This I here stands for the identity matrix. The identity matrix, I put two examples here. These are two examples of identity matrix. Basically, an identity matrix is a matrix where the main diagonal is all ones. You see the main diagonal is all ones, and all other entries are zeros. So the main diagonal is ones and all other entries are zeros. And when you multiply by identity matrix, it's just like multiplying by 1. You get the original matrix back. And so that's what makes these our inverse matrices of each other. This right here is going to come in very handy when we solve the systems. We're going to have to use that definition of inverse to help us solve when we get to solving the systems of equations. We're going to be using that concept. All right, so now that I know what an inverse matrix is, we're going to look at how to find the inverse. We're going to learn a couple of techniques today. The first technique is we're going to do row reduction by adjoint matrices. So this is our first technique, row reduction by adjoint matrix to find the inverse matrix. Okay, so basically we're going to go back. This is going to become very familiar to us when we did row reduction and Gaussian elimination, and where we ended up having our augmented matrix. We're going to make, so step 1, we're going to make an augmented matrix. That looks like this. Our matrix that they're given to us, and when we want to find the inverse to, augment it with the identity matrix, or that whatever matrix it is. Oh, and before I forget, just like determinants, only square matrices will have inverse matrix. If it's not a square matrix, the inverse matrix does not exist. And not all square matrices have inverse matrix. Okay? So I forgot this earlier, so let me go back to the screen. Okay? So only square matrices can have an inverse. So that's the first thing you check. Make sure it's a square matrix. Only square matrices have inverses, because notice all our identity matrices are all square matrices. And how to check if your matrix has an inverse is you look at the determinant. If the determinant of matrix A equals 0, then A does not have an inverse. And when we would say A is not invertible. Invertible is what we call for the process of finding the inverse. Okay, so A is not invertible if the determinant of A equals 0. So that's the thing you can always do to check and see if you're going to have an inverse or not, if it's possible to have an inverse. We want to start by checking and see if our determinant is equal to 0 or not. If it's anything besides 0, you can, and it's a square matrix, you can find an inverse. All right, so back to where we did that. So I forgot that earlier. So back to this. We need to set up our augmented matrix. So over here, I'm going to set up my augmented matrix. So that's going to be 1, 4, -1, -3. That's that A part. And then my identity matrix, this is a 2 by 2, so I got to do 0, 1, 0, 1. So that's my setup. And I need to see that on your paper. So you have to do your setup. Okay. Once you have your setup, we're now going to use all those row reduction process. And we're going to continue doing the row reduction. Our goal is to get the identity matrix on the left-hand side of that augmented matrix. So our goal is to get a 1, 0, 0, 1. Okay, that's what we're going to try to do our row reduction to get. So that's our goal now. And then if you get that, that'll be the identity matrix. And what's on this side of the dashed line is your answer. That's the inverse. Once you're doing those row reduction. So that's the process that we're going to go through. All right, so here's our augmented matrix. I want to get the identity, so I want to keep that identity matrix in my head. So I'm going to just kind of keep that in my head. This is my goal. On the left-hand side, I need to get this. That's what we're trying to get to. And so I see I already got a 1 in that first spot. So I need a 0 here. So what row operation can I do to get a 0 there? Okay, so I can take row 2 plus row 1, and I'm going to make that my row 1. Switch over. Okay, so we have row 1. We're going to make that row 2. Row 1 stays the same because it's already the 1, so that's 1, 4, 1, 0. Remember, I could draw it as a solid line or a dashed line. Okay, so let's try this. So -1 plus 1, that's 0. -3 plus 4, that's 1. 0 plus 1 is 1. 1 plus 0 is 1. Okay. Now, oh, that was nice. I already have the 1, and the 0. So now the only thing left to do is I need to get a 0 here. And then I would have my identity matrix. So let's see if we can think of a operation I could do. I can get a 0 there without messing up anything else. So -4 what?
R2.
R2 plus R1. And where are you going to put that?
R1.
Put that in R1. Okay. So let's see about that. So R2 is staying the same, so I'll just write it down. All right, let's try this. So -4 times 0 plus 1. Well, that's still 1. Yay. -4 times 1, that's -4. Plus 4, 0. Perfect. -4 times 1, that's -4. Plus 1, so that's -3. -4 times 1 is -4. Plus 0, that's -4. Okay. And now I've gotten step 2 done because I have my identity matrix over here. That's when I know I'm done. And so what is my inverse of this matrix?
-4, 1, 1.
You got it. -3, -4, 1, and 1. That is our first technique. You usually see this technique, you can do this with 2x2s and 3x3s. So we're going to, I'll pause and see if you can do this, find the inverse of this matrix. It's a 3x3, so what's my identity matrix going to be this time? Our identity matrix is 1, 0, 0. That's what we're trying to get to this time. That's going to be our goal. All right, so I'm going to set up my augmented matrix. 1, -1, 0, 1, 0, -1, 6, -2, -3. And that's with the identity matrix. So it's 1, 0, 0, 0, 1, 0, 0, 0, 1. So that's my first step in setting it up. Now the operations I do might be slightly different than what you did, but at the end you should get the same. So your inside matrices might look different. There's multiple ways to get to the same answer. I'm going to choose, because I got a 1 there, so I'm going to try to get 2 zeros here. So I decided to do R2 minus R1, and that'll give me my new R2. And then I took R3 minus 6 times R1 to get my new R3. So 1 is staying the same. And then when I take R2 minus R1, so 1 minus 1 is 0. 0 minus a -1 is +1. -1 minus 0 is -1. 0 minus 1 is -1. 1 minus 0 is 1. And 0 minus 0 is 0. Okay, so that one works out. Now I'm going to take R3 minus 6 R1 and give me R3. All right, so I'm going to do this one a little bit faster. That's 0. Whoops. Okay, so that is 0, 0, and 4, -3, -6, 0, and 1. That's what that one ends up being. All right, so I got a first column set up, 1, 0, 0. I already got that 1 there in my main diagonal for the second column. So what my next 2 steps is I'm going to try to get a 0 here and a 0 here without messing up anything else. So that's what I'm going to do next. And so I thought through this. All right. So I decided to, in order to get my row 1 fixed, I decided to do okay. So in order to get row that one fixed, I decided to go with row 2 plus row 1. Okay, so row 2 plus row 1, and that'll give me my new row 1. And then nothing for row 2, and then I'm going to take -4 times row 2 plus my row 3 to get my new row 3. See how I'm lining up my options with the rows I'm working with? And so row 2 is staying the same, so that's 0, 1, -1, -1, 1, and 0. So when I do this R2 plus R1, that'll give me a 1, 0, -1, sorry. -1 plus 0 is -1. Okay. And then we have 0, 1, and 0. -4 times R2 plus R3 ends up with 0, 0, 1, -2, -4, and 1. All right, that's nice. Look at that. I already have my row echelon form. I just don't have my reduced row echelon form, which which I'll need for this, because I have to get an identity matrix. So I have all ones in my diagonal, got all zeros over here, so I just need to fix now these two zeros. So now I'm trying to get this and this to be zeros without messing up anything else. And so I'm going to do, excuse me, my allergies are acting up today. Row 3 plus row 1, and it's going to yield my new row 1. And then I'm going to do row 3 plus row 2. So if I use row 1, it messes it out. So I want to stick with that row 3 with all the zeros. Gives me my new row 2. And so I'm going to keep that last row the same. 0, 0, 1, -2, -4, 1. And so I'm going to get 1, 0, 0, -2, -3, 1, 0, 1, 0, -3, -3, 1. Okay. Everybody okay on how I did that? So therefore, I have my identity matrix over here. So my inverse is equal to -2, -3, 1, -3, -3, 1, -2, -4, 1. And there's my solution using this augmented matrices with row reduction, elementary row reduction. Okay, go to Canvas, work the first 3 problems. So in these examples that we did so far, except for that last one, most of them weren't too complex. You're able to get, it wasn't too many fractions. It worked out pretty nice. I know these 2 examples I purposely chose my determinant was 1, so it came out nice and pretty. I didn't have fractions. So in the two examples I did here, my determinant was 1, so it comes out nice and pretty fractions. But that doesn't happen very often. Most problems, you can get some messy fractions, and you can get some messy determinants. And so this can become very, very long and tedious method of doing it. So we've come up with some formulas that make life a little bit easier. But unfortunately, this formula only works for a 2x2 square matrix. Okay, so here's how you do it. If matrix A is defined by my first element's A, B, C, and D, so that's my matrix A, then my inverse of matrix A will be equal to 1 divided by the determinant of A. Now refresh my memory. How do I find the determinant of A? How do you find the determinant of a 2x2? What was that?
A times B minus B times C.
So you're going to do your diagonal down. So that's going to be A times that B minus your diagonal up, C times B. So that's our formula there. So you might want to make note that that right there is equal to the determinant of A. So it's 1 over the determinant of A times by, and then we're going to do some little rewriting of this matrix A. How you do the rewriting of this matrix A is on the main diagonal, you switch those numbers. And so I'm going to write on this main diagonal, this is now going to become D here and A here. So you'll switch the numbers on the main diagonal. On the diagonal up, CD, you're going to negate those numbers. So that becomes -C and -B. So the opposite of what's in the C and the opposite is what is in the B. So you negate them. And that is going to give us our inverse. So to show you really quickly, I'm going to go back to that first one that we did today in our notes. We found that we had A is equal to 1, 4, -1, -3. So I'm using 1, 4, -1, -3. Now notice how much work it took us to get, we did all those steps. We had to do those different operations to figure out how to do that. Well, now I'm going to use this formula in blue to work this out. So I'm going to find my inverse. And it's going to equal 1 over, diagonal down, multiply together. So 1 times -3 is -3, minus diagonal up, multiply together. So -1 times 4 is a -4, so that becomes a positive. Okay, rewrite this. The main diagonal, the 1 and -3 switch, so it becomes a -3 on top and a 1 down here in the bottom corner. And then the other diagonal, the diagonal up, needs to be negated, so this -1 becomes a +1, and this 4 becomes a -4. Well, -3 plus 4 is 1. 1 over 1 is 1. So this tells me I now will multiply every term by that scalar multiple of 1. So that just gives me -3, -4, 1, 1. -3, -4, 1, 1. Check and see. -3, -4, 1, 1. So we get the same answer. I think this method is a little bit faster and easier to do, but you just have to know that formula. And you can do it using this method. For matrices of larger than the 2x2s, on the 3x3s, etc., we're going to use our calculators to help us out. So now I'm going to show you how to do inverse of matrix on your calculator. So we will find the inverse of, let's make this matrix, we'll do 1, 1, -2, -3, -2, 5, -6, 4, and 4, using our calculator. So, all right, so first thing you got to do, you got to put that matrix into your calculator. So I know you can't see it now, so I'll call it out to you again. So we're going to go back to our matrix menu. So second matrix, cursor over to edit, and we're going to put in matrix 1. It was a 3x3 matrix, so I'm going to put 3x3. And here was the one, it was 1, 1, -2, make sure you're using the negative button. -3 for the second row, -2, and 5. And then the third row was -6, 4, and another 4. Okay, so that should be the matrix that you have in. Double check and make sure you have the right matrix. 1, 1, -2, second row, -3, -2, 5, and third row, -6, 4, and 4. All right, so I've saved that. So I'm going to quit, go back to my home screen. And I remember to find matrix, an inverse of a matrix. What was our notation for inverse matrix? The power to the -1. So I'm going to do matrix, and I'm going to do matrix A that I just changed in there. And then I'm going to do this x to the -1 button. So I'm going to do, and that's saying find the inverse of matrix A for me. And then enter. Okay, and then how do we change back to fractions if we need them? Math, frac, enter. There's our answer. The only downside to this is sometimes you will see this instead of written as we have here of -14, -6, and 1. Let me write it on the board. So instead of seeing it written as it is written here, sometimes you will actually see it, they like to factor out that 1 over the determinant. So sometimes you will see it with that 1/2 factored out. And then you'll have the matrix like this. So I think I put that on a couple of the options. And so in order to factor that out, I originally had to distribute that 1/2 to each term. And so to take it out, what operation do I need to do? Okay. Multiply by what? Multiply by 2. So I can take my answer here and times by 2, and it gives me this matrix. So therefore, this right here is equal to 1/2 times -28, -12, 1, -18, -8, 1, -24, -10, and 1. So sometimes they write it like this. So just be prepared if you need, especially with the matching that you'll be doing. You might see the choices like this, or you might see the choice like this, but these two are the exact same answer. Okay, usually with the error, that probably meant that you used the minus sign instead of the negative sign. Oh, and you don't, you have to go, you can have that extra spot there. Yeah, it goes in. You have an extra spot here. Check your matrix A and make sure you use the negative sign, not the minus sign. All right, so that's how we're going to do some of the rest of the determinants. So now go back to the assignment and work through, let's see, what question? Number 7. So now work all the way through to number 7 using this new method. Okay, so now we're going to look at how do we solve systems of equations using what's called, using some inverse, using this knowledge we just learned about inverse and matrices. Okay, so what you're going to do is your step 1 is you're going to set up your matrix equation, okay? So set up matrix equation. Now, your matrix equation that you're going to set up, basically, you're going to make a matrix for all your coefficients. Just like we did before when we solved the system equations, we took the variables out and we just wrote the coefficients, the numbers in front of the variables. So we're going to make a matrix of all our coefficients. I call that the coefficient matrix. And then we're going to times that by our variable matrix. And that will equal to our answer matrix. Okay, so that's the first step. We're going to set up our matrix by make a coefficient matrix times a variable matrix equals to our answer matrix. And that's the procedure you're going to do. So I'm going to flip to the next page and show you the example. I'll do just one step and then you flip back to this. All right, so here is our system. So we're going to solve this system using inverse matrices. And in the system's x minus 2y equals 5 and 2x minus 3y equals 10. So my coefficient matrix is I just take the number in front of each of the variables. So remember, my first equation is going to be my first row, second equation, second row. First column will be all the x's, second column will be all the y's. So this will be 1, -2, and then this 2, and then the -3. That's your coefficient matrix. I took the coefficients in front of each of these variables, and that made my coefficient matrix. Then I'm going to multiply by my variable matrix, but I have to be careful. I have to write the variable matrix as a column matrix, because remember, in order to multiply, I have to have the same number of rows across as I have columns as I have numbers down. So same across as down. So X is written first and then Y. So that's how I'd have to write my variable matrix. And this is going to equal my answer matrix, and that's just my answer to equation 1, my answer to equation 2. So there's my answer matrix. So that's the first thing you're going to do is set it up. So we're going to set up our equation like this. Now I can check this. If I did multiplication, 1 times X gives me X, plus a negative 2Y gives me X minus 2Y. That's my answer there. Equals 5, equals that answer. 2 times X is 2X plus a negative 3Y. That's 2X minus 3Y equals 10, sorry. So that is correct. So I've set up my matrix. That's your first step. Step 2, we're going to use our knowledges of inverse in the identity matrix, because we want to try to get, and you can think of it like this. You can think of this is my coefficient matrix. This is my variable matrix equals my answer matrix. So think about that. I have that matrix A times X equals B. I want to find X. I want to find what the variables equal. So I want to get X by itself. So in order to get that X by itself, I recall from the very beginning of this lesson, I said if we multiply an inverse by itself, and when I do the one side of the equation, I got to do the other side. What did I say that the inverse times itself is equal to? I, the identity matrix. So I can make that the identity matrix. And the identity matrix by anything, that's the reason called identity, it's the same matrix. So that will give me my X. I would solve for X. That will give me my answer to my equation. So that's what we're going to try to do. We're trying to solve for X. And we solve by X by multiplying each side by our inverse of our coefficient matrix. So step 2 would be to multiply the inverse to the coefficient matrix and the answer matrix together. So in symbol notation, that's going to be, I'm going to have my variable is equal to the inverse of my coefficient matrix times by my answer matrix. So that's what we're going to set up. Okay, so back to our example problem that we were doing. My next work I need to show is I'm going to have my variable matrix equals, and now I need to find the inverse of this matrix. So I have my coefficient matrix is 1, -2, 2, -3. Okay, how can I find the inverse of that? 1 over -3, multiplying the diagonal down times the diagonal up, minus a -4 over
-3 to -2, 1.
Perfect. Flip these, switch these, negate those two. All right, so that's just going to give me -3, 2, -2, 1, right? Okay, so that means that's what I'm going to show here, my inverse. So that's what I'm going to write here, my inverse of my coefficient matrix times by my answer matrix. And that order is important. It has to be written in that way. So inverse the coefficient matrix times your answer matrix. Now I'm going to remember multiplication of matrices. right, so multiplying matrices. We go over and we go down, we add the terms. So -3 times 5 is -15, plus 2 times 10, which is 20. And then I'm going to go over and down again. Oops, missed it again. Okay, so now I'm going to go over and down. And so -2 times 5 is -10, plus 1 times 10, which is 10. So my answer matrix is 5, 0. I wonder if I can do this in my calculator. What do you think? All right, so you may use your calculator to help you out. Even if you use your calculator to help you out, I still need to see this work, and then this work. So that's the work you'll still need to show on your paper. So let's try this one with the calculator, see if it helps us. So I'm going to go make sure I got the equation written down. All right, so we're going to go back to our matrices. And now I'm going to edit in my matrix A, my coefficient matrix. So now this is a 2 by 2 matrix for this example. My coefficients was 1 and -2, 2 and -3. Okay, so I got 1, -2, 2, and -3. Also, so quit. I need to put my answer matrix in matrix B. That's a 2 by 1 matrix. And my interest matrix is 5 and 10. So we put in 5 and 10 to that. So I have A is my coefficient matrix, B is my answer matrix. Quit. Find the inverse of my coefficient matrix. So that's matrix A to the -1 equals, yay, we got what we did, -3, 2, -2, 1. So I can write that on my paper for the next line. Times that by my answer matrix of 5, 10. So now we're going to do that operation. So we're going to go back to matrix. I'm going to take matrix A, inverse, times that by matrix B. There's your answer, 5 and 0. So a lot of that you can do. And it's the same technique with a 3 by 3 or a 4 by 4. You do the exact same process. So questions over solving systems equation using inverses. All right, you may work the rest of the assignment.